All right. Great. Hal, go ahead and take it away.
Okay. I'll just share my desktop. I guess let me know if you guys can see this.
Yes.
All right. So you guys can see. Well, let me go play. So so you just see some random dots on here, right?
Mm-hmm.
Right now, green, some purple. You probably don't see there are little dots there. So this is basically I got this data from our school learning management system, CSOL, and basically I grabbed a month worth of data at the beginning of school last semester, not this year. This year things got really weird. And like last week we had like 2 days. The first day was online learning. And then Tuesday, Wednesday, we were on campus, everyone. And then Thursday, student was sent home because there's some COVID cases. We did online. And Friday, everyone, even including teachers, can't come to school because the road was blocked. Anyway, so it's crazy. And but things were somewhat normal, as normal as can go in January. So I did this whole January, from January 3rd to January 28th, a month of worth of data. So these dots represent items that people posted onto the system is purple, and then comments are green. So as you can see on the corner here, it's so there's about 6,000 comments on January 26th, and then there's some other little dots here as likes. If you post something, you can like it, and there's really tiny ones that parents would visit. 900 some of those. This doesn't really make much. You can't make sense out of this, right? It's just a bunch of random dots. But with the power of flow, we can see that I categorize them into the different items. So items, comments, likes, and parent visits. And the dots, the size of the dots actually represents the number. So basically at the beginning, maybe January 3rd, when it first started out, there were only 90 items posted that day. But when you get towards the end, like January 28th, there were like 5,000 items posted. So same thing over here in terms of comments. And, as you can see, the parent visits and likes are somewhat steady, I would say, throughout the time. So at the beginning, they're probably about 200, and then at the end, it gets to 900. Okay, so it's a more, later on. So if we break this down again, what I did was, instead of having so many dots, each dot representing a post or a like, I just categorize them into just how about, for each day, I only have one dot, and representing that all 5,252 comments on January 15th, this is one dot. So basically I would have in total about 120, less than 120, because it's like not entire months. It's January 3rd to January 28th. So about 25 dots per item. There are 4 different items. So there are about 100 dots here. And representing different items. And so if we now look at this, this is cleaner. And so basically in the beginning, so each row is 7 days of the week. So 1, 2, 3, about 3 weeks and 5 days are what this data is showing. So on the first day of the first week, January 3rd, we had 90 items, and then the second week, I think, is the best. And so starting out Monday, we have 500, Tuesday at 1,500, Thursday, Wednesday is 2,600, and Thursday, so on and so forth. So it's growing, and then and it gets pretty steady once the school gets rolling. The every day it's about 6,000 items posted. But in terms of parent visit, I think that is about 1,000. Once parents start engaging, it's about the same. Every day it's about this many parents visiting. Lastly, since this is a timeline, I did basically a scatter plot of, so showing that you can see the growth trend. Basically, the first week was pretty quiet, and then starting the second week on January 10th, Monday, January 10th, things starting to go crazy and going up. And then it gets to a bit of a plateau in terms of the school getting into a groove, into a flow, and things are steady. So that's the different ways to visualize this simple data set.
First, I gotta
Well,
say, your Chinese parents are the envy of the world to have that many visits coming to your school. That's astonishing and amazing and wonderful.
Thanks.
Yeah, that was a great flow. And I love specifically the last two steps where you go from this time series data where you're actually using each row to represent a week. And you can sort of visibly see the LAR or the size of the dots change. And then you're basically doing the same thing, but instead of using the size of the dots, you're using the actual offset or the Y offset or the height components as the dimension. And I think being able to show one value in multiple ways like this really builds a strong mental model. So I love the transition and sort of these experiments in how you're representing, to your point, like a pretty simple data set, but seeing it through different lenses, I think, yeah, adds a lot of value. And there's definitely some ideas I have as well, but yeah, other comments or thoughts on this? And anyone else that would like to take a minute to present, we can probably do maybe one more.
Yeah, and I just wanted to say hats off, Hal. I'm doing different, multiple variations on one data set to get at it and looking at it from different angles. That's really neat. So good work.
Thanks.
Definitely.
I agree. It really brings the mental model to life.
Okay. Anyone else that would like to present or share a bit of any of the homework they did? All right. Final call. 3, 2, 1. Feel free to go ahead.
Mine's real quick. I was
Yeah.
trying to add a bit more, but
Go for it, Jimmy.
I can throw on something here. Let me see. Works this time for me. Okay. So it's based on NOAA storm tracking data
Oh, perfect.
that they maintain for a global, all the storms that they follow over, and it goes back to 18 something. So I took out of that, I extracted everything that reached a category 5 and was in the North Atlantic. And you end up with about just under 40 storms total.
Nice.
And they have data, so they have readings every 3 hours, and they can show you then basically, you know, when the storm was first observed till when it was last observed. And this is based on the size of these dots in the random chart is based on the duration of the storm. So you can see Allen was quite a short storm, Inez was a longer one on that side. But then you can also look at how many hours it actually spent at category 5 rating. And then the picture looks slightly different, and you can see Irma was perhaps the longest of the category 5 duration storms. Whereas you can find, again, some of the other ones may have just reached that as a blip and gone out back into category 3, 2, 1. It goes negative categories. And it's actually quite a good data set, and there's a lot more I could have done with it. And I have a couple fumbled attempts at making more content, and I would like to keep working on it as things go. It even has some mapping data because I think there's coordinates. You can follow where these things were over time. So I'm interested in today's presentation also. Thanks, guys.
That's a really powerful data set. And,
Yeah.
you know, just off the bat, one of the first things that strike me is these kind of charts where it's a 3D scatter plot, which looks great when you're in headset, but at least on flat screen to see the dimensionality. One thing we sometimes do is just have one line that connects down to the grid. on the base or even to the sides that helps you sort of see the distance. We found that that's quite helpful to see that position to make it a little more concrete. But yeah, it's a really powerful data set, and we can definitely keep iterating more on it. But thanks for sharing. And I think we got cut off last time or yesterday when you were trying to present this, and so we were all like left in suspense. And then I think you had some connections issues. So I'm so glad you were able to come on today to finish
Second
it.
time lucky, at least.
Nope.
Yeah, a super neat data set. And gee, if there's information in there that could be tied into maps, that would really be neat.
Agreed. All right, cool. So just organization, I'm going to show just a few art of the possible maps here. And I'm going to share it sort of just over my shoulder here to start. And sorry, give me 1 second. Oh, does it keep going back? Okay, that's fine. All right, I'm going to take over screen control here. And I'll just share it this way. So just a few flows to highlight in terms of sort of art of the possible. And one thing I try to highlight is that with maps, because we have this third dimension, more typically when you look at a map and see things plotted, you'll see things like this, where it's a circle or a dot indicating the spread of something or where something's happening. But that with this third dimension, if we look at that third dimension as time, that we can actually use that time dimension to show how something changes over time. So now it's not only tied to a specific location on the map, but that the distance away is related to the time it happened. And so you can start to create these visualizations. We internally call this actually, we have a different one where it's more vertical, but it looks like a rain cloud basically over the United States. And it is, in this case, everywhere where there on a per capita basis, there was an outbreak of COVID, and hiding any dot where it was less than a severe threshold. And so you can really see how an aggregate in the winter of 2021, we see this large spike, but that then also geospatially, you can start to see more. And so I point to this not as like a revolutionary, but I think that's it points towards what is possible in the platform where you utilize this third dimension. And then not to go into too much more detail, but just a few visualizations that also utilize maps, but in sort of non-traditional ways, is a hierarchy view. So here, in this case, it's the total number of children under 6 years old is the height axis. And actually, I'm going to take it back a step and we'll just have it show just this one. So here you can see the total for the overall United States, and then you can also see each specific region, and then each region break down to the state, and then each state goes down to the county. And so it's 4 levels of data, and it's built as sort of this like tent pole hierarchy. And so this is another visualization that utilizes that third dimension in sort of a powerful way that can be extrapolated out to lots of different types of maps or other types of aggregations of information. And then just the last one to quickly show is, this was one where we're showing the movement of people. In this case, the movement of people from California, or anyone that moved out of the state of California, and where did they end up? And so the color of origin is, or the color that they are showing is where they're coming from, and then these are the dots of where they're going to. And so the idea of showing the flow of people, or the flow of something, supplies, other things related to maps, I think is another sort of intuitive, powerful component. And you'll notice that the dots will stack inside of each county that they're being put back into. So anyways, we're not going to go into building those in this session, but I just wanted to sort of put something out there to say, there's more that you can do that's not just putting a dot on a map, but you can show both animation, you can use the height axis, you can start to do things that leverage sort of the third dimension in a more powerful way. And similar to even the example that Hao showed and Jimmy, the idea of taking a dot and moving it through multiple steps, and that each step allows you to understand it a little bit deeper, a little different perspective, I think is all part of that storytelling process. So that is it for me. I will be on, and if you have any access issues or other things, do text me or put into the chat. I can go into a breakout room, et cetera, with you. And otherwise, I'm going to pass it over to you, Bill,
Okay.
to take us through the meat of today.
Good.
And before that, any questions or other commentary? Okay.
Okay, what we're going to do today is take you through what I call the fundamentals of maps. I teach a lot of courses here, and maps is, we always include a significant portion of a session on maps, because maps are very ubiquitous and flows that are developed. I would say out of every 10 or 20 flows that we get involved with developing or whatever, or we see being developed by our customers, probably a good 75% of those have at least one map on them. So it's a very common use case, and Flow is very good at visualizations by using maps. So I just clicked the Create New Flow button. So what I've got here is what you get when you create a new flow. I want to define what's going to go on with Swarm 1 on step 1. And what I'm going to do here is I'm going to put a map on this step straight away. Okay. So to do that, I'm clicking the plus map icon here. And then Flow is asking me, okay, you've told me you're going to do a map. What kind of map are you going to do? Well, we have about 12 or 14 standard maps. We have maps of Europe, and Europe including Russia and the UK and France and India. We did a big project for the UN having to do with Bangladesh. So we have a couple of Bangladesh maps in here too. For purposes of today, I'm going to use the world map, and there are several different ways we can express a world map. Here's an equal rectangular view. I'm not going to do that one though. I'm just going to take the spherical representation of the world in this session. We also have the capability where if none of our standard maps fill the bill for you, it's quite easy actually to upload your own maps. All you need to do is find a suitable file that has map information in it, create a type of JSON file, and then upload that. And then you can have a custom map that behaves just like any other map in the system. And we have about a five-page, easy reading kind of document on our help center that takes you through exactly how to do that. So if you go into our help center and just put maps in the search bar, you'll probably get about 20 or 25 pointers to different things. Some of them are videos, some of them are short articles, and there are a couple kind of user guides like the one for doing your own custom map. Okay, so I've got, and by the way, as I'm going through this, interrupt me at any point. Okay, so okay, I've got this map of the world. What am I going to do with it? Well, I'm going to put some data on it. So what I'm going to do here is I'm going to define what I'm going to be using for my swarm of data. Now, luckily, in our library, we have a data set that is comprised of information about the 10,000 largest cities in the world. So I'm going to select that. So this is going to be my data set. Okay, and just like we've seen before, when this swarm of data is brought into Flow, it's put into a random chart of dimensions 1 meter by 1 meter by 1 meter. And by the way, the world here, it has a diameter of 1 meter. Okay. So you can see that these dots kind of crisply encase the map of the world. Okay, so what's the next thing I'm going to do for this? Well, what I want to do is I want to put these dots onto this map. So it turns out we have a couple types of charts that have to do with maps. One is map from coordinates, and this means, hey, in my data set, I've got latitude and longitude coordinates that are going to place these data records onto the map. We have another one that's mapped to regions, which means, hey, I've got a country name or whatever that can place information onto the map. So this particular data set, I'll show it to you here, right here. This particular data set, first of all, it's got 10,000 records. And the records consist of city. Actually, we got a couple of representations of city. We got latitude and longitude, so we can place it onto the map. We got the country, we got the population, we got continent, and a few other fields. So pretty simple data set, you know, maybe 10 columns by 10,000 rows in this data set. So I do have my latitude and longitude in this data set. So I'm going to say map from coordinates. So Flo is going to ask me, okay, which map? Well, I've only got one, so it better be map number one. The latitude column, Flo makes an educated guess as to which columns in the data set could contain latitude information. And it turns out that the column called latitude does contain it. Similarly, for longitude, it's a longitude column that contains that. So immediately when I click on this, instantly, these 10,000 dots are now put onto the surface of the Earth. Okay? Each one of these dots, by the way, is of size 5. 5 is an arbitrary size. It's kind of a smallish size dot. If I wanted to increase the size of these dots, I can increase them to whatever I want. But for right now, I'm going to leave them at 5. Okay, so let me put some interactions onto these dots. I really recommend that this is done very early in the game. So what I'm going to do, I'm just going to put some query ability into these dots so I can see what's behind these particular dots. So to do this, I'm going to say on select pop-up. I'm going to create an overlay pop-up, which means the pop-up is going to appear here in the upper left-hand part of my screen. And when I say select columns, these are all those columns I showed you in the CSV file. So on the pop-up, I'm going to put the city, I'll put the country, I'll put the population, and I'll put the continent. Keep it kind of simple. And to make it easy to read or to understand which information is which in the pop-up, I'm going to put a little label within the pop-up, city, country. I'm going to abbreviate population, just POP. And continent, I guess I'll spell that one out. Okay, it's going to go in the upper left. Okay, in this dialog here, there's a lot of additional formatting and precision setting that we can do. On this one here, since some of these numbers, population can be like 37 million people, you know, that's 8 digits. Let me constrain it. So I'm going to be rounding the display to the nearest 1,000. Just going to make it the information a little bit more instantly readable if I express the population in thousands rather than units. So I'm going to click OK here. I'm just going to click on some dot here. Just a random dot. This is Yangyang, China, 61,000 people, and its continent is Asia. So this is how the pop-ups are going to work. So I'll be able to query what's behind any one of these dots. Okay, I've got clickability, queryability on here now. Now what I want to do is I want to generate some separation of these dots from the surface of the Earth in a way where the largest cities are the furthest reaching out into space from the surface of the Earth. So I'm pretty well trained in Flow. So I know what I need. What I need to do here is I need to click on additional dimensions to get this kind of functionality. And I'm looking for a height offset. I'm going to say height offset, and I want the height offset to be a function of a column of population. Okay. So I don't know if you can see it very well, but some of these dots are starting to get some separation off the surface of the Earth right now. Now, for my taste in this presentation, I want the separation to be more than what you're seeing here. So instead of a maximum offset of 0.1 meters, I'm going to change that to 0.5 meters. Okay, so now you can see some of these cities are getting some pretty good separation away from the Earth. Flow also provides me some high-level information here. The smallest city in my population of 10,000 cities is 40,000 people. The largest is 37 977,000. So 30, almost 38 million people is the largest city in this particular data set. Okay. So let's see, maybe this one, I'm going to make a guess that I haven't spun the world all the way around, but I'm making a guess that this is my largest one right here. It's way out in space here. Okay, Tokyo, Japan. Yep, this is the one that's almost 38 million people in the metro area in this particular data set, and it's in Asia. Okay, so I've got this done. This is better than where I was before, but it's still not very good in that I can't really tell where these dots are on the map. So once again, being reasonably well-trained in flow, I'm going to say, hey, new connections. This is the way I connect dots, either to each other or to surfaces of maps or other structures. So I'm going to say, I want to connect the dots to an axis or a map. Okay. And since I only have one map, Flow knew exactly what to do. So now what we've got here is we got each one of these dots is nicely connected to the map. It took about 3 clicks to do that. And now if I query on this dot again, this is my Tokyo, Japan. If I take a look at the map here, sure enough, that is Tokyo, and it's put in the right spot on the map. Let's just take a look at another really large city here and see which one it is. Okay, so this is Jakarta, Indonesia, 34.5 million people in the metro area. Okay, so all this seems to be working. So now for, I guess for reasons of presentation, I want to make the largest cities have larger dots. So I want the dots to be proportional to the population of the cities in my data set. Okay, now notice down here in this objects timeline, I've got my discolored cell here is connections. I'm looking at the definition of connections 1. That's the last thing I did over here on the right-hand side of the page. So, over the screen. So what I need to do here is I need to click on the accompanying swarm of that because I know that dot size is a swarm attribute. So I've refocused on my swarm. So now I've got my definition of swarm over here. And on the options I have for dot sizes, well, I can use the fixed dot size as 5, which I'm doing right now. I can scale the values according to some column, or I can even set the dot size directly from the CSV file. The particular one I'm going to use here is I'm going to scale the values according to column population. Okay, oh, so I do that, and now instantly my dot sizes are proportional to the population of the cities. Took about 4 clicks to do that. So, and now I've got the larger dots here, they're a little bit easier to click on. So here's my Tokyo again. Okay, in addition to dot size, a very common use case is to make dot color an attribute of these maps. So I'm going to keep things simple here on this particular map, when I look at my colors options here, I can set a gradient scale. I could use this color scheme if I wanted to. I could even put the hex values of the color in a column in the data set. What I'm going to do here in this example, I'm going to use a gradient scale. And once again, I'm going to colorize by population. So, you know, about 3 or 4 clicks there, and I've got my dots colored according to population. So Tokyo is a very different color than all these other small cities along the surface of the map. Flow, by default, makes the low end of the scale correspond to a neon green, our standard neon green dot. And it makes the upper end of the scale correspond to purple. So I'm not exactly sure why that was the default, but it's flexible. I can set this. So instead of having my largest dots being purple, I'm going to make these dots the brightest red I can find in my color palette. So I did that just by clicking on this and then using my mouse to click out to find a very red color. So here's Tokyo. It is pure red. Jakarta is not quite as pure red, but close. And then here's another large city here. Let's see which one it is. This is Delhi, 29 million. So I'm starting to lose a little bit of the red, and I've got this as an orange tinged dot. So what I'm seeing here is a regular progression from green to red. There's nothing sacred about always using our neon green dot. So a lot of times I like to use kind of an aqua colored dot. So I just chose aqua here instead of green. And now I've got this representation. So going from aqua to red instead of neon green to purple, I have gotten a little bit more definition of differences in colors for these dots. So in any case, all these dots are of a particular color as established on this using this gradient scale. So that's all I'm going to do for the cities part of this map. But another important aspect of maps is to use what we call choroplaths. Now, I'm not sure if you know the meaning of that word. I did not know before I started at Flow. But a choroplath is a capability for colorizing regions on the map, such as countries, in this particular map, according to some metric that's in your in the CSV file that corresponds to countries. So what I'm going to do here is I'm going to click on map. I know that choroplathing is a map attribute. So I'm clicking on map and I'm coming down here, and I know to establish a choroplath, I'm going to have to define a source data file. Okay. So I'm going to come over here. I'm going to click this hamburger icon. I'm going to come into data sources. And you see here, I've got my 10,000 cities data set. That's the only data set I've put into this flow so far. I'm going to create a new data set here that's going to have country information, including country population, so I can colorize the countries according to the population of the countries. Okay, so I've created my new data set here. Now Flow is asking me to go out and find it. So I'm coming out here. I'm going to choose the file on my hard drive. Okay. Let me just type in, I know the folder that this is in. Okay, and I know the particular file that I have has the word country in it. So, okay, so here it is right here. Country world population 1. This is the data set that I knew of on my hard drive that contains the information I want to use to drive the colors of the countries in this map. So I click on it, I open it. It's being read into Flow. It's got 237 rows, one for each country of the world. And the data set consists of a couple different spellings for country. Value, this is the value of the population. It's also got a ranking. I ranked in this data set, I have all the countries of the world ranked in their, according to their population. So China is the most populous country. I also have a column of convenience, which is called population in millions. It's just this number here divided by a million, so population in millions. And I think that is, yeah. I have a few other fields in here. Oh, you know what? I'll mention this one here right now because we're gonna use it a little bit later. A little bit later, I'm going to generate a colorization of world countries according. So I put the 10 largest countries. I'm going to make them red. I'm going to make the next 10 orange. And the next 20, I think, are going to be blue or something. So, what I'm doing here is I'm just setting this up. So I'm going to be able to conveniently colorize countries in groups, in blocks of size, rather than doing a gradient from the smallest to the largest. And I'll show you why that's going to be the case in a couple of seconds. So that's my data set. Okay, so I'm coming back here. I'm going to click on the map again here, get focused back on defining the choroplath. Now I know what my data set is. It's going to drive the choroplath, and it's country world population 1 CSV. Okay. Now, when you have a map, there are regions of the map that indicate boundaries, in this case of countries. So the region column that I have that matches with what's internal to this map is the country name. Okay. I'm going to scale the value here, and I'm going to be using the population in millions column. Okay. And I'm going to range the color from yellow, which represents 1 million, to bright red, deep red, which represents 1398 million. So this is 1.3 billion people. Okay, now it turns out the facts of life in the world these days are China and India are by far the two largest countries in the world. So basically they grab all the red, okay? Since this is a linear gradient from 1 to the size of China, you know, India and China are the only two countries here that really turn out to look red using our default gradient here for Choroplath. If I look at the United States, which is the third largest country in the world, I do see it's a deeper color than a lot of the other countries. It's kind of an orangish color. And Brazil's another large country. So, you know, these countries are ranging from yellow to red, but the way the data lines up in the world, there's only really two countries that turn out to be red. So in any case, I've got all this into my Choroplath now, and perhaps this would be suitable for what I'm using it for. So, you know, be like 7 or 8 clicks to do that. Okay, I'm not satisfied with this though, because I'd like to have a larger number of countries have a rich color just for my presentation purposes, whatever those are. So instead of scaling the Choroplath from 1 to 1398 and going from yellow to red on that scale, how about if instead of using the column of population in millions, I use this population section column that I showed you earlier. So in this particular, using this particular column, I'm only ranging from a value of 1 to a value of 5. And 5 represented the 10 most largest countries in the world. 4 represented the next 10 largest and whatever. So now I've got a much richer variation of color because I've contrived my data set to, so when I do a linear choroplathing here, I get something that is just more interesting to me. So in this particular case, I mentioned the 10 largest countries of the world are value of 5 or red. Right here in this swath of longitude, you can see 6 of the 10 largest countries of the world right straight away. We've got Russia, China, India, Pakistan, Bangladesh, Indonesia. Those are 6 of the 10 largest countries of the world. We spin the globe, we see Nigeria as one of the largest countries in the world, Brazil, United States. And I did not realize till I did this training course that Mexico is actually the 10th largest country in the world. Okay. The next 10 largest are these kind of rose colors, and the next 10 I think are these kind of orangish colors, and so on. So anyway, that is a, you know, here what I've done is I've modified my data very easily, and it just took me a few minutes to do it, but in exchange for that, I got a much richer colorization of these countries of the map. Final thing I want to show you is it's possible to control the precise color of every country, every region in this map. So in order to do this, instead of, actually, you know what, let me save this. This is going to be my step. I'm going to make a copy of this step and do my modification on the following step, just so I have both steps to refer to. So now I'm on step 2. I'm looking at map 1 on step 2. And instead of scaling the value here, I'm going to say the value, the value of the color is in a column in the data set. And the particular column, well, it's not going to be population section. It's going to be a column that I call section color. So here, what I'm actually doing here is I'm getting the color for this choroplath by reading in the CSV file. And let me show you what that looks like here real quick. So I'm just going to look at the data set again. This is the data set. Oh, I'm sorry. That was a rookie error. I don't want to look at the data set for the cities. I want to look at the data set for my countries. Here it is. It's this this column here has hex values for the colors I want to do for every country. Now it turns out here I kind of set these so the 10 largest countries were this dark red, and then the next one were a particular orange that I wanted. So, you know, but if I had wanted to, I could make every country have a different color if I wanted to, just by putting a different hex code here in this column in my data set. I'd have to come up with 237 different colors to do that, but you know, you could do that if for some reason you wanted to do it. So in this case, what I'm going to do here is I'm just going to live with what I've got here. Here I've got the 10 largest are red. The next 10 largest are this kind of bright orange. The next 10 largest, I think, are maybe the blues or whatever. So in this way, I'm able to precisely control the coloring of the regions of my map. So that's all I'm going to do on this. I still have a couple other things that I want to show you, but let me pause here to see if you have any questions on this. And Michael, I'm going to admit Julian. Looks like he's in the waiting room. Just
Yep.
click admit. So I just noticed that just now.
Yeah, I think
So
I just-
let's see, any questions on what I've done so far for maps or Choroplath? Okay. Okay, these are the basics of using any of the maps in the system. They all basically work the same way. You can colorize all of them. And you just have to, you want to make sure that in your data source that you've got the, you've got columns that allow you to do these kinds of things.
Sorry, Bill, one question before you move on. The map, the globe that is in the flow system already has knowledge about borders and the names of the countries. You don't have to match that to some existing data set that you guys use. Like, does that know that's India? Does that know that's Saudi Arabia?
Yeah, this information is contained in the map. And if you ever want to find what the region names are in the map, there's a button here called Get Available Regions. So if you look at the CSV, if you look at the particular CSV file that contains your map, you can get the regions of it by clicking on this Get Available Regions button. So what I did here is I downloaded to my hard drive the regions of the map.
I'll just add to that our like world map has a whole bunch of aliases. Basically, each time the World Bank or UNDP send us a data set, and they send us spreadsheets that don't exactly match what's in our data set, we update this map to take advantage of those new names. But in general, it is nice for you to, like, especially if you create your own custom maps or someone who's created a custom map for you, it's nice to see exactly what matches, because we do need exact matches between the region name and the data in your data set.
Can anybody tell me how you can easily, using Flow, find all the missing names or the mismatched names in your data set instantly?
Great question, Bill.
Okay, the way you do it is you do exactly what I've done here. Don't worry too much about the exact names of the countries, and go through this choroplathing step. And any place where there's a mismatch, it's going to be a gray color. You know, so actually I use that technique to debug some files that we've gotten from different agencies within the UN and the like. And almost every time I get a map, there's one or two mismatches in some country, usually not one of the major countries, but some country will show up as being gray. So then I see what the spelling is. If it looks like it's a common spelling that we're going to encounter again, I send into our engineering group an alias for that country, and we put it into the maps. So gradually over time, we're accumulating quite a few variations on how different countries are are designated. Okay, so maps are a lot of fun, very colorful, really useful, and a very common use case in Flow. Okay, I'm going to close this flow here. By the way, let me come back into this flow because it can. I'll show you a couple other things I can do with it here.
There is a
Sorry.
question from John Porter as well about converting CSVs into JSON. So I'll just quick answer that, which is that if you scroll up your chat window, there is a link that Michael put in for custom maps, which tells you exactly how to work through that. Essentially, there's some really nice online tools to find. First of all, there's lots of shape files in the world, and this document tells you how to find some of those. Second, it tells you how to convert those shape files to TopoJSON with an easy online tool, including optimizing it, because some shape files are hundreds of megabytes large, and this is a web product. We don't want people to have to download a 100 megabyte file to get down to every last little corner of the shoreline of a country, and then options how to export that and then upload it into our system.
Okay, thanks, Jason. Okay, one other thing I would just want to show you what to do. A best practice that we always recommend is name your flow with a reasonable name. Instead of having a name new flow with a date string after it, name it with a more meaningful name. So here's Certified Flow Designer Map Training version 1.0B, because I did this same kind of presentation yesterday, and that was version 1.0A for the people who came to the Tuesday session. So give a meaningful name. Another thing is sharing. Sharing is quite important in Flow. We support different ways of sharing. This isn't a course on sharing right now, but what I'm going to do here is I'm going to share this flow privately, and I'm going to share it with an organization near and dear to my heart, our Flow QA organization. I'm going to share this flow with it. So now people like Michael, Jason, and some other people in the company here can access this flow, and they can make copies of it and do with it whatever they want. So just wanted to get in a plug here for sharing. Okay, now I'm going to exit this flow here. Okay, and I'm going to put a filter on my flows. I've got hundreds of flows from all around the world that people ask me to take a look at. So I got one of the most interesting jobs in the world, I think. I get to witness this creativity that's going on all around the world with Flow. Let's see, what I want to do is I want to take you through custom maps. And I'm going to also take you through custom maps in edit mode here. Custom maps turn out to be really easy to do. But by far the hardest part is to find the file out on the internet that has the map of interest to you. But there are good sites that have those kinds of maps. And we have, as I mentioned before, in our help center, we have directions on how to do that. Okay. So here are a couple of custom maps. 6 or 8 months ago, I had occasion on consecutive days to do training session for people in Kansas and people in North Carolina. So I thought it was just good form for those training sessions for me to make some custom maps to those 2 states. So I went out to the Stanford site and I found files that had map attributes for the state of Kansas by county and for North Carolina by county. And I followed the process in the manual that we published in our help center. And to do the Kansas map, I was forging new territory here. It probably took me 35 minutes to do this custom map, but there was a steep learning curve in that. I kind of perfected the steps I needed to do. And when I did the North Carolina counties map, it took me like 15 minutes. So steep learning curve, but custom maps are quite easy to do. In order to check out, to make sure I had all the counties' names spelled right here, I put in kind of a crazy Choroplath here. Let me show you what the data set is for this map here. It's one of the world's simplest data sets. I've got the county name within the state of Kansas. I've got a value from 1 to, I think there's 105 counties in the state of Kansas. And I just did a random number generation here, and I put numbers ranging from 1 to 5 in something I call dot value. I just wanted to check out everything about this map worked okay. So very simple data set, 101 record for each county. And then I set up my Choroplath on this, just like I did when I was talking with you. Turns out the region name in my custom file is called name10 : Greeley. Okay, I think that's Greeley's an example. So it's name 10 was the region that corresponds to the county names in this map. So I established that as the region for my custom map. And then I set up the data file. I did put in my in this data file. I had the county this what I call the value column here. It went from 1 to 105, where the lowest county name alphabetically was 1, and the highest county name alphabetically was 105. I did that, and the primary reason I did it, it's kind of crazy to alphabetize county names, but I wanted to find if anything showed up as being gray in here, because that would mean the name I have in my data file did not match the name in the map. So it turns out they're all nicely colorized. This one, the richest red one, maybe is this one. Yeah, so this is really near the bottom of the alphabet, Wilson. It's the 103rd county in alphabetical order. And if I can find the very brightest yellow one, maybe this one here. No, this is the fourth one, Barber County. So there's some county in here that begins with the letter A, and it will have the brightest yellow. I did the same thing for the North Carolina map. So, really easy to do. And once you have your custom map set up, these maps behave exactly the same as any other maps in the flow system. So that's just a few words about custom maps. And then every once in a while, you might come across a situation where you just can't quite find a map that does exactly what it is you want it to do. And maybe you might you might need to go out and just take a picture of a map. This is something we did for a company in the DC area. Oops, this is my human body. Sorry about that. Got the wrong one. Yeah, so this is something we did for a company in the DC area. So what we did is we took a picture of a map. We took an image, basically took a photo of the map, put it onto a step. And what we did is, looking at this map, we were able to find the latitude and longitude of the 4 corners of the map. Then what we did is we knew, so these become the boundaries of the latitude and longitude for this particular image. And then what we did is we knew the latitude and longitude of the various buildings that we were trying to display on the map. So this then just became a linear triangulation, let's say, or I'm not sure what the right word is, but a linear honing in on what the locations of these particular properties were. So this is property 13, had 870 square feet. We put just some simple kind of clickability on here, but this takes a little care. You have to make sure you know the latitude and longitude of the 4 corners of the map. But once you have that, it becomes very easy to place. If you know the latitude and longitude of structures that you want to show on the map, it becomes a very easy thing to do. So that's an example of using a picture of a map and using it constructively for holding scatter plots. Okay. So now just to put a teaser here, if you can do that with a map, you should be able to do it with just about anything. So what we've done here is we took a picture of a human body. Turns out this was a drawing drawn by Leonardo in the 15th century. And this was for a medical kind of application. What we wanted to do here is we wanted to display some incidences of pain points on the picture of a human body. So what we did is we took Leonardo's drawing and we put some scatter plot information on it. This is a clustered swarm that shows each incidence of pain kind of clustered around the point where it happens. This is more classical scatter plot where we're counting the number of incidences of pain in the neck, pain in the left hip, pain in the right hip, and the wrist, and the like. So that was a pretty interesting flow using exactly the same technique that we used on the map of the Washington, D.C. area.
So Bill,
Okay.
sorry, you're still using latitude and longitude to create those points?
No, no, we didn't use latitude and longitude, but we did use X and Y. And like this is the 0 point for X and Y. And this is the 200 point. And this is the 0 and the 200 point. And what we did is we defined each point on the body to have an XY coordinate. But it's pretty much the same, exactly the same concept.
Yeah.
So,
If
I guess we could have
scale,
called this. I guess it would have been fun maybe for us, instead of using X and Y, to use latitude and longitude. Then we could have put that on this, but we figured that might cause a bit more confusion than we were up to at that time. So anyway, there's lots of techniques that images and maps can be used in doing visualizations in Flow. So let's see, let me pause here. Any other questions on this kind of technique or anything else we've talked about?
Can you show what the CSV file looks like that overlaps the coordinates, the Y and the X with the image?
Yeah, this one here?
Yes.
Yeah, okay, let me go up to this swarm here. So you're asking a question, you want to find the XY, you want to see the CSV file for the swarm that corresponds to this step. So I focused on the swarm for this step. And now what I'm going to do here, I'm going to show you the CSV file. So the CSV file is body part location, left foot, left hand, left hip, etc. 8 locations, I think. This is the number of occurrences of pain at that location. And what we did is we did a little bit of measurement and an approximation, and we came up with XY coordinates for these various places. So the left foot has actually, let me take this one. The left hand has a large X coordinate and kind of a medium Y coordinate. Let's see if that makes sense. So the left hand should be way off to the right and kind of in the middle of the picture. Yeah, so really simple. I'll just put that up again for you in case you wanted to take a mental picture of it. And once again, what we did here is we made this point here, we just defined this point here to be the 0, 0, and this to be 200, 200, or maybe it turned out to be 210, 200 due to the dimensions of the sketch. And then we just, we kind of approximated it, and with 1 or 2 iterations, we were able to get these points directly where we wanted them. Okay, anything else? Okay, well, great. Well, thanks for listening. I will stop sharing here. And by the way, this flow that these flows that we create during these sessions will be made. You'll be able to link to these flows, so you'll be able to reverse engineer anything that you saw me do here today.
All right.
Okay, back to you,
Bill,
Michael.
Yeah, thanks for going through all of that. I think maps is a very exciting area for lots of experimentation, and one of the easier ways to think of 3D spatial visualization is just show people a map first. It's the easiest thing for anyone to understand of like, where's the value of 3D and where can you derive value, and it's a pretty easy shoe-in. And I think going from there to then some other visualizations often lends itself really well. So homework will be the same as last week, which is basically to take this topic we just went through and to find a similar data set. We'll send out a data set that is geospatial or geospatial data contained within for you guys to practice on. But you can also pull from a variety of sources to create your own data story that uses a map to show some mastery of that, and that will be available for any help or assistance with that. In the chat window, you'll also make sure to reference, there's the demo media folder, which I'll encourage everyone to reference, that has some other sample data, but other topo.json files if you want to play around with some of the custom maps and some of the functionality there. Otherwise, thank you guys so much for your attendance today. Really exciting to see the energy here. Any other questions? And similar to last time, we will have the beginning of the session open to anyone that wants to present. So Jimmy, thanks so much for presenting. And then I totally lost track of who Hao. Thank you, Hao, for presenting as well today. So yeah, thank you guys. And any other questions to wrap things up?
Yeah, I just wanted to say, this is a big product. It's got a lot of options. And some of the things you're doing with this product are probably pretty new to you. If you get to a point where you figure out there must be an easy way of doing what I want to do, but you can't quite figure it out, then send us an email. I'm very happy to help you out if you're hung up at some point. So Yep.
Is there any more kind of fine detail guidance for what you want us to present next week besides something containing a map or not?
Yep. Yeah. Thanks, Henry. So I don't, as of right now, but we'll send it in an email. It is pretty broad here in terms of the homework assignments. We're not educators and we're not keeping grades. It's more to prepare you for the capstone project. And so we're working further on the details for the capstone of what we're expecting. I can show you a little bit of what we've been working on, but we have now, between Bill and I, one Excel sheet that contains basically every function in the whole, in all of Flow. And we're basically using that as sort of a rubric to make sure, one, that we cover everything, and that two, it's a way for us to assess people's capabilities within the different functional areas of the app. So we can be more specific in the actual ask here. And so in our summary email that we'll send out tomorrow, we'll try to be more specific, but hopefully that gives a little bit of guidance that, these homeworks are meant to be, but.
yeah, Alpha just asked a question about when the capstone needs to be ready by.
Yep.
I don't know if we have a date on that, but yeah.
We don't have specific dates. It's going to be starting scheduling the week after our last session. So we have 4 sessions here, and then we'll start scheduling for the week after. And we'll probably be hosting them during these regular times on Tuesday and Thursday for people that want to present in front of others. And then for anyone that wants to present privately and not in sort of a session like this, that we can do those separately and just schedule them separately. So that's the game plan there. And Anushree is on, and we're deep in the work of outlining all of those details right now. But thank you guys all for your patience and flexibility as we've been building up this certification program. Cool. All right. Well, until next week, feel free to reach out, and thank you guys so much.
Yeah, thanks. Thanks, guys. Good seeing you.
All right.
Bye-bye.
Thank you. Have a good night.
Bye-bye. Yeah, same to you.